Hi everyone, this is Mayur and it's definitely a pleasure for me to meet all of you. It's been a while for I was thinking I would come online and I would uh, conduct few session for you guys so that you guys would understand how exactly you could build your career in autonomous vehicle segment. But due to my busy schedule and due to other responsibilities, I was really not able to take out time from my schedule and manage the sessions. But I think like now I'm little relieved from the responsibilities that I was supposed to be taken care of. And now I can like take out some time and I could like talk to you guys and conduct a session and tell you exactly what exactly you really need to learn in to be good in autonomous vehicle segment. Uh, so let's get started. So when we talk about autonomous vehicle, at that time one would might think they would just need to know about autonomous vehicles or like the software related to that, but it's not all. There are a lot of things that we need to learn about. As you all know, when we think about means we could take like closest analogy to the environment, and as we know, in environment there is always some sort of chain that exists, and one thing is dependent on another. So, in order to do this software development effectively, what all things that we need to do is we need to we need to learn a lot of other tools, and that's something would help us to excel in this domain. So, first of all, let's say you are totally new to software development, then first of all you would need to learn what all kinds of like means what's the hardware, what's software, um, and then what's software development. Basically these are things that you really need to know. You need to be good at data structures, you need to be good at algorithms, and once you're like good at those things, then you could like think about learning these tools. And those tools would be like, first of all you need to learn about the code editor. So code editor is a place where you could write your code and it would get like debug, or that something would help you catch bugs in your code. So basically these are like syntactical error that you could like catch over there. So that's the one thing. Second thing is that like means you could learn about a compiler that you would notice. Basically it depends on the kind of language that you want to go ahead with. If you just choose like Python, then you really don't need any compiler over there. It's like interpreted language, so it would basically just come with like interpreter. But if you choose to go ahead with like C++, and in that situation you really need to make a choice about what kind of compiler you would need, and that thing in principle would depend on what kind of operating system that you are using. So if you are like sure about all those things that are there, and then operating system as well, uh, the operating system one would want to go ahead with like Microsoft Windows, and one might want to go ahead with like this Linux, Ubuntu or whatever like version that they would want to go ahead with, or they could just opt for like Apple systems. So basically these are the things that are available over there. But basically one would need like operating system, then one would need like code editor, then compiler. And going forward, you would also need tools that would allow you to like test your code. So there is a gtest, then pytest is also there I believe for Python. And then you would also need to check the coverage of your code. So you need like those tools that you should be like aware about. And once you like learn about those tools, the next thing is you need to start learning about your domain, and that would like autonomous vehicles. And in this autonomous vehicle, so simple pipeline, there are like various approaches that we could take. First is the modular approach, and another is end-to-end learning approach. So in case of the modular approach, we would like split this entire pipeline that we would need into small blocks, and then for each block we would build software. So that would be the like, thing. So first of all we would have like perception block. That's something to take in data from sensors and would try to convert them into some meaningful information. So take in raw data and convert them into meaningful information. Then there would be like sensor fusion block. So sensor fusion block would try to take in data from like multiple sensors and convert them into like meaningful track information, so that if there are certain issues that are there just because of like measurement uncertainties or like sensor uh, insufficiencies, then that would be like taken care of by sensor fusion module. Then that data would be further passed on to prediction module. Prediction is again two types. So short term, long term prediction. So basically short term prediction is something would be taken care inside sensor fusion block if they are using like Kalman filters. And long-term prediction is basically about the trajectories and intents of other vehicle that would be like taken care of by prediction block. So and then it goes into planning module, and planning module would again be like divided into various levels. So basically global planning. So basically it is where trajectories would be means path would be decided on how exactly one should we get from one location in city to another location in city, or like one city to another city. So high level path, then the one that we get with like Google Maps. Then second is like behavior planner. So basically it's like with time horizon like 5 to 10 seconds, so like what maneuver that we should like undertake in order to drive effectively on the road and be consistent with the uh, objective that we have gotten from global path planner. And then lastly we have like local planners. Basically it's divided into two parts: path planners and velocity planners. Basically it is where like path would be trajectories would be created and velocity profile would be developed for that. And then comes control block. Control block would again be divided into longitudinal and lateral control. In At lower speed it works, this decoupling block between longitudinal and lateral control. But if you think about this thing at like higher velocities, in longitudinal and lateral control decoupling might not work, and we would need to consider them together. But inside longitudinal lateral control, basically control signals would be calculated like throttle, brake, and steering angle, and those things would be sent back, or those things would be sent to the hardware, vehicle hardware. And when we want to teach this thing in like closed loop simulation, those things would be sent back to the simulator, and simulator would like based on that generate new states of like environment, and send those things would be then picked up by sensors, and then this whole cycle would repeat again. And second is this end-to-end pipeline, where we would just taking data from sensors and would generate like this control signal like throttle, brake, and steering angle. So this is second pipeline. These all things we would like discuss in detail in like later videos, but that's all for today. I hope you liked this video. Let me know what you want to learn more about, or what topic you want me to talk about, and based on that I would create like another video and I would post it on YouTube. Thanks for your cooperation. Yeah, see you soon.